All right, good morning, 11:34 a.m. on February 17th, 2021 at Liberty High School. This is the Principles of Engineering course. I've got Ryder and Javian and Luke and Lewis and Ethan sitting right here in front of me, and I'm trying to teach them simultaneously while I am teaching kids on Zoom who might be listening at home. They're not. And then I'm also, on top of that, I'm recording this so I can post this on my YouTube channel later. I'll put a link in Schoology if you want to look at this again. Okay, the idea is that this is lesson 1.1.5, which you find right there in the Project Lead the Way website, of course. 1.1.5, gears, pulley drives, and sprocket practice problems. So there's really not much here except a document which shows the problems that you need. And so what I did, rather than have you deal with that, I put in the Schoology course page, I put 1.1.5 gears, pulley drives, and sprockets practice problems. And then I put snips of those problems, which I just use the snipping tool to get those problems easily accessible within Schoology. So I'll look at that in just a moment. But when we do this assignment, we're actually going to need notes from a previous assignment that we never did, which was 1.1.3. Let me show you what I'm talking about here. This is my engineering notebook, the simulation of my engineering notebook. And if you zoom in a little bit closer and look at this very first page of my engineering notebook entry for 1.1.5 gears, pulley drives, and sprockets practice problems. What I want you to know, and I'm not going to go over this, you guys in front of me know exactly what I'm saying. I'm not going to go over this in detail, but I do want to remind anyone doing this assignment, you do need the introduction and the resources from 1.1.3 in order to do this problem. Or these problems, especially this particular equation, which is GR, which is gear ratio, is equal to N sub out over N sub in. N is the number of teeth in a gear, which does not apply to pulleys, but it is part of the equation. And then this is D sub out over D sub in. That's the diameter of the gear or the pulley. And then this little thing, let me zoom in closer on that so I can sort of explain what that is. I'm looking at the screen in front of me, which I shouldn't be because there's a lag there. Okay, so N is the number of teeth in a gear, does not apply to pulleys. D is the diameter of the gear or the pulley, D sub out, D sub in. And by the way, the outs and the ins refer to the power that is being, the input power, which is being applied to one of the pulleys or gears, and then the output power or the output motion that the dependent gears and pulleys get from it. This will make sense in a moment. Well, what I really wanted to point out here is this little variable, which is a lowercase omega from the Greek alphabet. And so it looks like a real curvy W. And so from now on, I'm just going to call it W, even though it's actually an omega. And it is W sub in over W sub out. And what does that W represent? It represents angular speed. Angular speed refers to how fast something is spinning. And then here's another Greek letter called a tau. I want you to think of like a towel, like a beach towel, except you cut off the second syllable and it's called a tau. If you just want to think of it as a T, it is the facsimile of a T in the Greek alphabet, which is a tau. Tau sub out over tau sub in. And what does tau represent? Well, I said N is the number of teeth in a gear, and D is the diameter of that gear or the pulley in today's lesson. And then this little w is the angular speed, how fast it turns, usually in RPMs, if you know that unit, RPM, revolution per minute. But this tau, or T, I'm going to refer to it from now on, that is torque. Torque is a quantity that is based on a force that is applied over a distance. It's a rotational force that is applied in the rotational sense. And that actually is not going to be part of the problem that I'm doing today, even though it's in this assignment overall. Okay, so if I zoom back out of this and zoom back even more, if I zoom back out of this, these are all the notes from the previous assignment 1.1.3 and the equation that we just discussed. I know you can't really read that because it's zoomed out so much, but underneath that equation is where the actual, that's probably, it's okay. Underneath that equation is the actual introduction that goes with 115. You can look at that for yourself. I'm not going to spend a lot of time doing that. Ethan, are we good? Okay. And then the resources from this assignment, remember, that is just the document, and you actually don't even need that because I put it in the Schoology course page. Remember that. Okay, we'll come back to that. And so the procedure for these problems, and I do want you to write this down, everything that's in blue here is a simulation of your handwritten ink on your notebook page. And then I do want you to write down the procedure for this, which is to solve problems using the GUESS method. And the GUESS method is GUESS, which stands for given, unknown, equation, substitution, and solution. And then in this particular assignment, it turns out that there's 4 problems. It looks like there's 10, but there's actually 4 problems. And the reason it looks like there's 10 is because the way that they label it in the assignment is step 1, step 2, step 3, step 4. But those 4 steps are one problem. And then it continues like that. Oh, by the way, I have a big empty space here, so that's why I drew a line through it and signed it. You can't leave empty spaces. So a lot of what I just said is not really what I want to talk about right now. I want to pick one of these problems, and the one that I'm going to pick is the 3rd problem, which in the assignment is labeled step 8 through 11, and I'll show you that in just a moment. Going back to here, the snips from the problem. Problem 3, this is the one I'm looking at. Problem 3, steps 8 through 11. Problem 3, steps 8 through 11. And then this is just the problem as it comes straight out of the Project Lead the Way document that you don't even have to look at now that I've given it to you. And so in this problem, this is like a physics problem. I teach physics upstairs, and I teach physics problems with that GUESS method. And so here, everything up to this point was just the preliminary. And so now this is where the action is, this one problem that I want to try to help you solve. In a pulley system, pulley A is moving at 1,500 RPM, revolutions per minute, and has a diameter of 15 inches. 3 pulleys, B, C, and D, all different sizes, are attached to a single output axle. Speed and torque output are changed within the system by moving the drive belt between pulleys B, C, and D. And I will admit to you that the first time I read that, I had no idea what they were talking about. Maybe you feel that way too. Maybe you can empathize with me being confused and frustrated when they describe something I can't even figure out what it is. However, after I thought about it, I started to realize that it is what I've drawn here, which is a pulley system. Well, pulley is a rotational circular piece with a belt around it. And so a pulley takes a pulley A has to be connected to pulley B, and that's this big one here. And however, it does say that there's smaller pulleys that are concentric to the first pulley, which means they're just circles inside of circles. This belt can be moved off of the B pulley and onto the smaller C pulley, and then it becomes a different arrangement. It can also be derailed and re-railed onto the smaller D. The smallest one is D, the medium one is C, and the big one is B. A is the extra big one, the extra large one. A is the driver. In other words, that's where the power is being applied. Whatever motor or mechanism for turning this thing is being applied to A. The other ones just go along with A because A is driving a belt and the other ones move along with it. That's how a pulley works, I guess. So in this problem, it said all of this stuff. Pulley A is moving at 1,500 RPM. 1,500 RPM is like a circular velocity, or what they actually call it is an angular speed. Revolutions per minute, that's an angular speed. Well, I know from looking back at the equation in the notes from 1.1.3, there are PowerPoints in there. You can look at that yourselves. Well, I do know that angular speed is represented by this little w. This little w is 1,500 RPM for angular speed. And that is the angular speed of pulley A. So that's why I put this subscript A. W sub A equals 1,500 RPM. And then in the problem, after it talked about the speed, then it had a diameter of 15 inches for that pulley. So, well, diameter I would have figured out as a little d, but that's also in the equation and in the PowerPoint notes. So D sub A, because it's pulley A, is equal to 15 inches. That is given. The sketch that I've drawn is given, so to speak. It's given as words, and I turned it into a sketch. Remember, it's guess. Given, equation, unknown, substitution, solution. So far, I've only written the given, and there's a long way to go with that. And then it says the pulleys are attached. I already got that. If I scroll down to the next part of this, it says the speed of 1,750 RPM is required when the belt is connected to B. What is the diameter of B? Okay, so looking back at this picture, well, I've got the A driving the B. Don't worry about the C and D right now. C and D aren't even part of it. The B is the one with the belt on it. And they did give me 1750 RPM for the angular speed of the B portion of the pulley. And that is W sub B for angular speed. And then it's asking for the diameter. If I remember this correctly, do I need to pop back and look at that? It's asking for the diameter of B, which is D sub B. The diameter of that pulley is equal to question mark. Now I've got the given and the unknown. That's good. Given, unknown. Now I need the equation. Well, if you remember from way over here in my notes, that came from the PowerPoint, that came from an assignment that we didn't do, which was called 1.1.3. I got this equation. And so what I do, because the guess method tells me to, the guess method tells me to write down the given and the unknown. Whoa, it's really super laggy. I'm sorry about that. The given and the unknown and the equation. The equation that I wrote down is n sub out over n sub in equals d sub out over d sub in. Remember, this is not number of teeth. And actually, that doesn't even apply, but I wrote down what I saw. And then d is the diameter. This little w is the angular speed, w sub in over w sub out. And then this is t or tau for the torque, t sub out over t sub in. And you're probably thinking out and in, what's that all about? Well, the n sub out is the B, because that's what's coming out of the pulley system. The n sub in is the A, or that's what's going into the pulley system. Oh yeah, I forgot. N out and N in don't even apply because they're the number of teeth. This is not a gear system. But D for diameter and W for angular speed, that's exactly what I need. D sub out over D sub in equals W sub in over W sub out. And if you want to try to remember this is a little thing that I thought of. I hope you're impressed. You won't be. Is that for all of these quantities, notice there's 4 of them. They are all out over in, out over in, out over in. They're not really all, because there is one that's in over out. This is the only one that's reversed. So think of it this way. It's out over in unless you want to win. Get it? See? You like that? Out over in unless you want to win. And then it would be win over wout, or W sub in over W sub out. So here I have the equation that I've manipulated to serve my purposes, which is D sub out over D sub in equals W sub in over W sub out. Well, in the given, I was given W sub A. Well, W sub A, I'm going to replace the W sub in with W sub A. I hope that makes sense what I just did there. And then D sub A, well, D sub A, I'm going to replace the D sub in with D sub A. And then the W sub B, which is now the out, the W sub B, I'm replacing the W sub out with the W sub B. Wow, this is confusing. D sub B is now the D sub out, and I've replaced that there. So if that made any sense, which I think it probably didn't, this is kind of the problem I had yesterday explaining it, that I kind of got off track. But I got D sub out over D sub in. Trust me, that's D sub B over D sub A. And then I got W sub in over W sub out. Trust me, that's WA over WB. And I am looking for, remember the unknown was D sub B. I am looking for D sub B, as in boy, and I'm going to rearrange this equation using algebra skills to get D sub B isolated, and I do that by multiplying D sub A times W sub A. What do you know? D sub A times W sub A. And then divided by W sub B is still there. This is not nearly as confusing as it sounds, I promise. Now, given, unknown, equation, GUE. There's 2 S's in the word guess. The first S is substitution. Here I have substituted 1500 for the W sub A and 15 for the D sub A. Remember, those were given for the A pulley. And then W sub B, I substituted 1750. I did some mathematics, multiplying and dividing, and I got 12.9. The unit of diameter in this case is inches. Okay. If any of that made sense, the next parts will make sense as well, because the next part, after the question for pulley B, the next question is for pulley C, which has a different speed, and they're asking for the different diameter. And then the next part is about pulley D, which they give you a different speed, and they're asking for a different diameter. So the process is just going to repeat itself. This belt is just being shifted from the B to the C. So the numbers change. A is still the in. B was the out. Now C is the out. A is still the in, and then D, B, and C were the out, and now D is the out. Now, I don't want to spend much more time because you're already tired, but here is the way that all worked out. The 12.9 inches that I already got for the B pulley, well, I did the similar process, and you can look for yourself to see how the C's and the A's and the A's and the C's and the D's and the A's and the A's and the D's. You look at that a little more closely and see that each of these W's that we were given are going to give a different D value. And notice appropriately, I hope I got this correctly, but I feel pretty good that the 12.9 is bigger than the 11.2, which is bigger than the 6.9. Remember, the B pulley is bigger than the C pulley, which is bigger than the D pulley. So those numbers, at least the numbers make sense. If the math is wrong, whatever, I apologize. So I think it's time to wrap this up. This took like twice as long as I had hoped it would. You know that there's all these other problems there for you to look at, so please do. Students here are already ready to get back on it. I hope you are too. I'm going to stop recording and hope that your day goes well. So bye-bye for now.